the whole idea on this particular station here, I want to welcome you over here, and thanks for sticking with all the tours this afternoon, is you heard this morning, one of Jason's comments is, if we're going to boost soybean yields and get out and beyond our 45 or 50 bushel county average goal, what do we got to do? We've got to feed the bean. We've got to feed this crop as a commodity crop to push the yield on this one. Because if we don't feed it, we're simply not going to get there. If we depend upon soybeans, that we're going to feed through the corn system and just let the soybeans take what's left and do that, we're going to be stuck in that 45, 50 bushel. I've been stuck there. I haven't been able to try to boost it. Now, I have produced 70 bushel beans on these plots, but where do we start? Well, I think we've got to get more nutrition out on soybeans. My basis is the first thing I do in all my plots, and this is my standard now, is I put 150 pounds of MAP and 50 pounds of potash on my corn and on my beans. That's enough for removal. If you look at your nutrient removal charts, for 70 bushel beans and for about 200 bushel corn. That's removal. I'm not moving my soil tests at all. That's just what the crop's going to take off of there. So maybe I get a little bonus in here. My corn sucks it up a little more. I have a little better than 200 bushel corn here the last few years especially. But that's a basis to start with, is I'm feeding the soybean for a commodity crop in that year. I'm putting MAP and potash on this fall on the corn crop that's out here when I get the corn done, or next spring ahead of my soybeans. That's the basis. Now the next thing is I think the number was, and it's right where I expected it, that about 2/3 of you don't do a starter on soybeans. Now, how many of you have a starter on your corn planter? Most everybody does. This is a very simple thing to do. Take your same starter that you have. I don't care what it is. 1034, 820, 723. Those last two are proprietary ones from Acre. 723 is a low salt starter. And put 3 gallons of starter underneath your soybeans through that same plant. Now I want you to use 5 gallons of liquid. I'll explain that one why here. When you put 5 gallons of starter, which is probably your rate you're doing, 5 or 6 gallons on corn, your droplets coming out of like a totally tubular unit right underneath that seed are about that far apart. If you go to 3 gallons, what happens to them? They go about that far apart. The problem is we're looking at soybeans. How far are your soybeans apart in a row? All like that, right? So now I've got soybeans in here that don't ever get you started. So go take a tender truck that you've got, or a wagon, or another tank, put your starter in there, add water to it. Get your application rate back up to 5. Now my droplets go back to like this. And now I hit my soybeans, or I'll hit more starter. So add some water to it. It's pretty simple to do. But put starter on soybeans will be their first thing to do, and we've already got the equipment. There's not even an equipment investment. What does it do? Well, soybeans are notoriously hard to show anything out in the field out here. Matthew can attest to this one. I think we were looking at things out here. What does it take to produce a bushel of soybeans out here in the field? Say I've got 140,000 plants out there. What's a unit of soybeans weigh? Roughly. That's a unit. 140,000 unit weighs roughly 50 pounds. What's a bushel of beans? 60, right? So I need like 1.2. That's 1.2 beans per plant and a population of 140,000 to be a bushel difference. Okay? So how do I show that? How do you end up applying? It's almost impossible to do. That's always been the challenge on beans. Corn, I can pull ears. I can show you. I go from 14 to 16. That's pretty easy. I can show you length. I go from 38 to 40 years, whatever. Beans is really, really hard to do. But one of the things that we do out here in the plots is I learned this from some of the seed guys, is go out into every treatment, the same distance into every treatment, and to pull out 2 foot of plant root. And I take and I bring them back up to the end of the field. You pull all the leaves off of them, and you pull the pods off of them, and you show the plants, and you show what's called pod mass, which is what I've got in here. So, untreated, no starter, there's the plants, 3 gallons of starter. Now, it doesn't look that much different. There's a little more plant here, a little greener. These were picked a week ago. Well, let's take a look at the pod mass here. I have 734 grams of pods here. I have 942 grams of pods here. Now, when I get to the end of the year, just round numbers, does this mean this is going to be 90 bushel and this is 70? No, it's not going to be that way. They're going to shrink. But what I have had over doing this, over the years that I've done this, which is 6 or 7 years I've done this kind of test, I've never had treatments get out of order. The differences will shrink, but the relation between the treatments will always stay the same. This is going to out-yield this. Now, I've looked at about 6 years of data here, 6 or 7. I've got to remember about how far back my calculation goes. I think it's 6. My average response to a 3 gallon an acre rate of starter using the current year's commodity price and current year's starter price has been about a $40 ROI. I'm not kidding you. $40 ROI average over that many tests, probably 15 tests in those years where I put a starter where I have it. It's a very simple thing to do. We've already got the equipment, put a starter on. Now, just like we do in corn, can we add to that starter? Yeah, we can. We can do some things to make nutrients more available. In our corn starters, we talk about a product, we had a group of products we called yield enhancing products this year, YEP products. And your agronomist may have visited with you about them. It's a system of products that really work together and are synergistic to each other to be able to make a crop production system. So if we're looking at fertilizers, we start out with high quality nutrition. That's our starter fertilizer, like a product from Integra. A723 is what I'm using here. 723 4. It's got 1% sulfur in it and 1/4% zinc. It's got some boost to the crop, obviously, as a starter fertilizer. It's a 50-50 ortho-poly blend, so it's lower salt. So that's our basis. That's good crop nutrition. But you can pick 820 from us, 825 with 4% sulfur and 0.5% zinc, or 1034, whatever you want. Now, what do we do to boost it? Well, one of the things is we got to make sure that the nutrients, once we put them in the ground, can get to the plant. That's a product called SyncRx from us. You've heard of like humic acids or fulvic acids. This is a refined fulvic acid. It's called crenic acid. This is what the product looks like. Dark brown product, very high quality product. You can mix it with your starters and it will not ever come out of solution. So you can mix it now, and even if you carry starter over the winter here, it'll still stay in suspension and won't settle out. What that one does is makes the nutrient transport more efficient. From where we put the nutrition right underneath that seed, we got to give it someplace to hang out so it doesn't get tied up in the soil, so then we can get it into the plant. That's what SyncRx does. $4.75 an acre, pretty easy investment, and we've seen some really nice ROI to it. Beans really respond to some other things as well. One of the things they absolutely respond to is a PGR, a plant growth regulator. I've used this factory analogy to talk about crop production as a factory. So every input then has some effect on that factory. What's a PGR do? Well, the plant's our factory, right? What a PGR does, a plant growth regulator, is it adds more roots, more shoots, more leaves. All right? I'm boosting up that entire factory, making the whole factory bigger. So I create more demand, but I create more potential output as well. Soybeans really respond to a PGR really, really, really well. Things like Ascend from Winfield United. Sygen is one we're taking a look at from CHS. A lot of other companies have PGRs as well. But what are they doing? Well, they're making a bigger plant, a bigger factory out here, potentially bigger yield as long as we've got the right nutrition and the right conditions that go along with it. Soybeans really respond to that extremely well. PGRs, we always think of them on corn, but actually PGRs started really their work on cotton. They're really broadleaf products. And so we get a very good response on there. Now we can also add biologicals in there, just like we do on other biologicals, not for nodulation, not for nitrogen fixing, but general biologicals that will help release nutrients off the soil. We've had good luck with using a product called Foster from Rosen's, but there are other ones on the market as well. I think there's something to these products. We've certainly proven a nice response to be able to release these products These biologicals produce enzymes that release things like phosphate off of our soil. Beans are big phosphate hogs as well. So if we can release phosphate, I think we can boost our yields out there. So this was Foster plus the PGR. So I think just starting with starter is something we can do a lot of difference on boosting soybean yields. Breaking out of that 45 bushel, 45, 50 bushel window that we've been operating in, US-wide and here in South Dakota as well. So that's a basic thing, and it doesn't cost much to set up. Let's move to the other end down here. We'll take a look at some other things that we can do to boost that nutrition for soybeans again. A kind of unique little new area, or newer area, I think maybe a renewed area is the best way to put it, is what happens when we raise a corn crop. How much nutrients does a 200 bushel corn crop take up? How much potassium does a 200 bushel corn crop bring up? It's like something like, I remember the number right now, I'd have to look it up, but it's like 500 pounds of potassium going to that corn crop. Now we remove part of that, about 70% of that with the corn yield, but there's a bunch of it that stays in that residue. So now we've got potassium goes up into that residue, and we got to leach that out of there if we want to make it available to the next crop. Well, how do we do that? Well, maybe if we're doing light tillage, maybe we knock the stalks down. We depend upon them breaking down. But there's a whole group of products out there that are biological products for residue management. As we get bigger and bigger, tougher corn plants, taller corn plants, we've had some 8, 9, 10 foot tall corn out here. It's a lot of residue out here. If we want to break that down, what's one of the things you could do is maybe consider a biological organism. For a long time, I didn't give these things a lot of faith. They were hit and miss when they were tried. They were terrible to handle. They were high use rate. You need like a gallon an acre of some of these, and they were just very difficult products to handle. They didn't have a very nice formula. Well, like everything else, they've really worked on them now. I think there's something to them. We tested them right behind the tent over here. So I've tested 2 different products. This one happens to be from Meristem Ag. It's called Excavator. What I did out here was, again, this 2-foot a row thing, but I went out here and did just an untreated plot. If you walk into that untreated plot right now, I can take corn residue from last year, take it and bend it, and it'll still crack. I can still get the rinds to crack on the corn stalks. So then I added nitrogen to it. I put 5 gallons of UAN on another treatment, just straight UAN, no biological, just UAN. Why did I do that? Corn residue has really, really high carbon content. If we want the organisms to do anything, we got to balance that out a little bit. We got to get them some nitrogen to be able to help break down that residue to get the organisms that naturally do this out in the environment to be able to have something to live on. Part of our nitrogen fertilizer goes to break down last year's residue. That's why in beans, we have a little bit less of an issue because we got a little more nitrogen in the residue. Bean residue breaks down right away. It's gone by next year. Corn residue isn't. So let's add some nitrogen. Well, it didn't give me any pods out here. It didn't give me any more pod mass here recently. But now I added the biological to it. Did the biological without the nitrogen. I gained quite a bit on pod mass here. Then the nitrogen and the biological, and I gained a tremendous amount of pod mass. Here, this one is 1,211 grams versus my untreated over here is 855. Now, did this really give me nutrients? I went out 2 weeks ago and did a soil test out here, 0 to 6 inch soil test to see if I actually got nutrients. This combination gained me 100 points of potassium level on my soil test, 0 to 6 inch. That's a lot. What I say was one of the biggest nutrients that goes up into residue? Potassium. Potassium's water soluble. It'll leach out if you break the residue down. I got 100 points there. What surprised me is my Olson phosphate test went from 12, which is pretty good, to 22. Now, is it going to be 22 for my corn next year? No, it's going to react with the soil. But available phosphate right now, I went up to 22. Now, in the last 5 weeks, we had rain up here. Yep, we've had 6 inches of rain up here. These soybean plants took all that available nutrition, says, I know what I can do with that. And that's where we got this growth. Is that going to happen every year? I don't expect it to, but I think there is something to these. If you've got really high residue, like you're going to do corn on corn, you had irrigated corn, those of you that are from up north where you can irrigate a little bit, you get a lot of residue out there. There might be something to look at with some of these biologicals. I'm not going to widely recommend them yet, but it's certainly something to take a look at. And I think the formulas are a lot better, so I think there's some progress being made. Next thing, when we put soybeans in the ground, we need to put some type of lubricant in our planters to make the planter go. We usually use talc or graphite or a combination product thereof, right? So, but can we do something more? Can we take that opportunity to put some nutrition down to the beans as well? Well, I think we can. We have sold a product called PMZ Dry. It's now been renamed. It's owned by Coke now. It's called Protivate NU4. It's been a talc and graphite replacement product. It's got a little bit of crop nutrition in it, some phosphorus, some manganese, some zinc in it. That's the PMZ. Been a pretty good product for us. But what about on soybeans? What do soybeans need? Well, one of the big things soybeans respond to is molybdenum, moly. So if you go to a moly and a boron and you add maybe a little bit of iron or something like that to the talc and graphite, can I get a boost on soybean growth? Yeah, I think we can. Now, talc and graphite's 60 cents a unit, something like that. Are these products, these newer products, going to be a little over $2 a unit? Yeah, I think they are. They're probably going to be priced in that range, but I think there's something to them. A newest one that's out there is this company, their product called Revline Hopper Throttle. It's again from Meristem Ag. I think you've probably seen these if you looked in some of the farm magazines. They're the bucket of talc and graphite, and then on top of them they look like they've got little syringe buttons on the top. Well, what they did was taking a look and saying, okay, what can I put in that bucket? Well, let's say I want to put, and for soybeans, I want to put an inoculant in there. Well, if I put a living inoculant, Bradyrhizobia bacteria, and I put it in talc and graphite, is it going to survive? Probably not. Talc and graphite's really a desiccant, right? It'll dry it out, it'll probably kill them. But can I put them in a little bucket, little plastic thing, got a foil seal on the bottom of it, and can I put that inside that bucket of talc and graphite with a little plunger through it that'll punch through that foil, and I'll keep my bacteria alive in that little pustule, if you will, or that little packet, that little box inside there, until I'm ready to plant. Now I pull a seal off, I push the plunger down, it breaks that foil seal, drops that inoculant, in this case, into that talc graphite. I shake up the bucket and I treat my 20 or 40 units of beans, whatever it is, and be able to put that product down to resident beans in that. Kind of neat idea. Kind of market disrupting idea, actually. Ways to put things into crops that we want to be able to specifically put in there. We're testing it. The first year we tested it, we did one on corn, we did one on beans. We had a couple growers be able to use these as well. So I think it's a neat kind of concept to be able to add something more to that talc and graphite. But again, the whole idea here, feeding the bean, going back, can we add a little bit more nutrition when we do that? Something we need anyway with the seed fluency agent. I think there's something to it. And in beans here, we'll show you the yield responses here. But this is NU5 versus a talc and graphite here. That's quite a bit of difference on those plants. Just adding a little bit of that moly in this case. Got those beans out of the ground. They also get better nodulation when I add that micronutrient in there. What if we want to make big differences? That's what this whole last section is, and what Jason was talking about. If we want to take and add a high amount of a starter fertilizer to soybeans, how far can we go under the seed? I don't think I covered this section yet, did I? If you want to go under the seed on soybeans, how many gallons of starter can you put under soybeans? Do you know what the limit is? I talked about doing 3, right? I talked about it down there. Why did I talk about 3? 3 is kind of a magic number. You can go 5 underneath soybeans pretty successfully. What happens when you go to something like 8 gallons though? These beans look pretty good. This is 8 gallons of starter right underneath the seed out here. I planted 140,000 seeds out in this plot. I have about 122,000 final stand out here because that's just the normal stand loss. Even with the seed treatment, that's about what you get. When I went to 8 gallons of starter, I'm under 100,000 plants left. Why? Soybeans can only take so much salt right in contact with the roots of the plant. Now, I have a handout way down on the end there. Some of you got that handout. You can grab one of those later. There's a chart in there, a test that I did in 2017 on this very plot here where I did soybeans in 2017. I did 3, 5, and 8 gallons of 1034 underneath soybeans at that time. And guess what? 3 looked fine, 5 looked a little better, 8 fell off the charts because I did the same thing. Has the world really changed on how much soybeans will tolerate for salt? No, it hasn't. 3 looks good, 5 looks a little better, 8's too much. So that's what I can do right under the seed. But what if I can separate it just by that far? Maybe a furrow jet takes it like an inch away. Furrow jets work great if the soil is good conditions, if it's not too dry and crumbly. If it's really dry and crumbly, I squirt it an inch off, it might fall back in furrow. That's been the limit on the furrow jets. That was another technology that we can add on the planter. Well, what if we go 3 by 1? And so we take and do those conceal units. 3 inches over, 1 inch down. How much can I dump out there? Well, the answer is a bunch. A little bit of soil separation will allow us to put a tremendous amount of starter fertilizer out there. So we went out here, we tried this. Let's go 3 gallons underneath the seed. Keep that going on there. So that was with 2 gallons of water. So I'm keeping that application rate at 5 gallons. Use another liquid system and push 5 gallons of old 1034 out there, 3 by 1 on the beans. Compare these to the no starter over there, or just my 3 gallons of starter. I think there's a bonus here. What about 10 gallons? Okay, this is 10 gallons of 1034. There's more pods here. The plants aren't that much bigger. There is certainly more pods here, a little more nutrition out here. Again, what do beans respond to? Well, they respond to PGR, and they also respond to another nutrient that we didn't talk much about, and that's sulfur. So let's add a PGR. 3 gallons underneath the seed, 5 gallons of starter out there with a PGR in there. Even out at 3 by 1, so the roots grow into the PGR. They didn't get the dose of PGR till mid-season. Those are pretty good. But this is the most impressive one here. Take a look at this. This is 2 foot a row. This is 3 gallons under the seed, 5 gallons of 1034 with a PGR and a sulfur source. Now, in this case, we use Taurus sulfur from Rosen's. It's a very good product. But could we maybe go with sulfur source also with something like ATS, ammonium thiosulfate fertilizer, or potassium thiosulfate for a little less cost than Taurus? Well, maybe. Or could we just go to 820, one of our starters from Integra that's got 4% sulfur built into the starter, and dump a bunch of that out there? But the combination of these, think about this one. This is 3 gallons under there with that extra starter. Hold up that one down right here, right inside there. That's 3 gallons of starter alone. Compare 3 gallons of starter alone to this. Now, what's the difference in cost? About 27 bucks difference in starter here. This is a $40 starter program. That's a $13 starter program. Now, what do I need? That's about 2, maybe 2.5 bushels of beans right now. Cost? Am I going to get 2.5 bushels difference here? Yeah, I think pretty easily, right? I want to raise 70 bushel beans out here. I think I got it here. Now, it's a lot of cost. There's a lot of cost of equipment in that. So let's talk a little bit about that. How do we average out that cost of equipment? Well, I think if I can continue to get these yields, I think I'm going to see it pretty quickly, because I've got to add a whole nother liquid system. I get that. There's a big investment there to be able to do that. The other thing, though, that's a hidden bonus to you as growers, and I credit Dustin Christofferson from our Innovation Center at Bowdle for bringing this one up to me. What is it worth to you if for the next 3 or 4 or 5 years, you take your average soybean yield from 45, 46 here in the county, and you move it to 54 or 53? What does it do to your APH?
Protection.
Yeah, your APH goes up, right? What's that for a value to you? That's a hidden value. It's not something we monetize right away, but that's a value to you when you've got to look at what it's doing for your crop protection out there from your insurance point of view, if you can raise your bean yields, that averages maybe even on a year where we don't have a real positive, great return on something, or even maybe a little bit negative, because it's going to be a little negative for the first bit. You're going to have some cost out there that you're not going to fully get back. But that's one of the hidden values that's in there, is that you're moving your APH forward, which is a positive for you long term. So consider that one. Is there an opportunity to feed beans? Yes. If we want to move beyond a 50 bushel average, what do we got to do? We got to put nutrition out here. We got to feed the beans for the commodity crop that they can be. We know the yields can go up. 200 bushels been done. That's going to take a tremendous amount of crop nutrition. But even 70, you can look at my handout there and see what 70 bushels takes. It takes quite a bit. Can I do it with 150 pounds of MAP and 50 pounds of potash, with an inoculant, and with 3 gallons of starter? Yes, you can add up the numbers from my soil test out there, and you will get enough nutrition in there with that program. But that's an investment right there of 150 pounds of MAP and 50 of potash plus starter. But that gets me to a potential for 70 bushel yield out here. But can I push it further? I think there is some opportunity to do that, investing in equipment, using the planter that we've already got, maybe adding some equipment to it, or maybe just adding more starter right where we got it. If you're not using starter, start using starter on beans, because I think there's some potential to feed the bean.